Forces and equations of equilibrium. Intermediate hinge at C. Intermediate hinge means 0 moments at C. The beam can be represented as such. The beam is divided into AC and CB. AC carries the part CB at C. In other words, CB is supported on AC at C. Link members. We have 3 conditions for link members. Hinged means it starts with a hinge and ends with a hinge. Straight, indicating that it can never be curved. Unloaded, and so the loads affecting the links are applied on other parts of the structure or directly on the hinges. Forces. Forces are divided into external forces and internal forces. External forces are divided into loads and reactions. We have our frame here, represented by this little child here. The child is loaded with a green force here, represented on the beam by those green forces. The little child doesn't pierce into the ground because of the purple reactions here, represented by the purple reactions on the supports on the frame. That's not all. The child is suffering from inside. There are forces on his bones and blood vessels, on whatever is inside him. We can never see those internal forces unless we have a cut. The cut here is represented by the different cuts on our frame here. So, to sum it up, the external forces are green loads and purple reactions. Internal forces can be deduced from the red cuts we have in the frame. Equations controlling the equilibrium of the beam. We have 3 equilibrium equations in plane. Sigma forces in the x direction equals 0, sigma forces in the y direction equals 0, and sigma moments at any point equals 0. Those 3 equations, each of them applies for the whole structure. We have an extra equation if we have an intermediate hinge. That is sigma moment about the intermediate hinge for part of the structure. Either the left part or the right part equals 0. Again, the first 3 equations apply for the whole of the structure, while the last equation applies only for part of the structure.